We're now going to completely switch gears and look at angle measures. We've dealt a lot with lines and line segments. We're now going to look at angles in section 4. So section 4, we're going to measure and classify angles, and then we're going to identify and use congruent angles, which also includes the angle bisector. There's a ton of vocabulary in this section. You're going to want to get this all written down. I'm going to show you how to label a lot of this stuff and where it comes from. So a ray, we're going to say it has one endpoint and extends indefinitely in one direction. So it's kind of like a segment and a line combined. I'm going to show you how to label and name a ray. I'm going to put a couple points on here. I'm going to say A, B, and C. So notice how I have an endpoint, A, and then it extends in one direction with the arrow. I can name this ray one of two ways, AB or AC. Notice in both ways I name it, I start with point A. Those are the only two ways to name that ray. You have to start with the endpoint and then pick a point in the direction that it goes. The next vocab word, opposite rays, that is just a fancy term for a line. It shares one endpoint and go in opposite directions. It's basically a line. What I'm more concerned about now is the terms angle, sides, and vertex. An angle is formed by two non-collinear rays. Remember, non-collinear are points that do not lie in the same line. So XY and YZ. Those would be non-collinear rays with a common endpoint, X. That common endpoint we're going to call the vertex. And then the sides of the angle are going to be the rays. So side XZ and XY. There are 4 ways that we can name this angle in this particular example. I'm going to show you how we can name all the different ways. One way is to use 3 points. So for example, I can say angle Y, X, Z, or angle Z, X, Y. Notice which point is in the middle. X, the vertex point. Sometimes they will also give you a number. In this case, they do. So we can also name this angle 3. And then finally, at times, you may only need to use 1 point. For example, I could just call this angle X. The only time that I can use this 1 point is if there is only one angle that's associated with it. So if I draw in another ray out of this, maybe call this point W up here, then I would not be able to use this option because I don't know if you're talking about this angle or this one that's associated with X. That's where you would need to use 3 points or a number. The last thing that they talk about is what is the interior of an angle and what is the exterior of an angle. So points like S and R would be in the interior of this angle, and M, Q. And then points P and O, those would be considered exterior. They're outside the angle. Some examples that are associated with this, name all angles that have B as a vertex. There are 2 of them. You can use 3 points or you can use numbers. I'm going to use numbers. So I'm going to say that angle 1 or angle ABD, you could have also named it that way, or angle DBA. And then the other one would be angle 2. So angle DBC or DBK, DBL, you could use any of those points on that ray since they're all the same. Those would be the 2. Name the sides of angle 3. When I'm talking about sides, we're talking about rays. So in this case, I'm talking about ray CE, that's one of them. And the other one would be CB or CA. Letter C, what is another name for angle GHL? The easy one is just to flip the order and go LHG. That's another name for it. H still has to be in the middle because that's the vertex. Or if we go up to the top, we could use a number. GHL, that would be angle 7. And then finally, name a point that's in the interior of angle DBK. We'll find this DBK. There's our angle. The point on the interior would be point E.